The function of an electronic oscillator is to convert direct current to alternating current by continually looping the signal through a feedback circuit. An oscillator is made up of two components. One part is an inverting amplifier, which, as we have discussed previously, amplifies and inverts the signal. Therefore, the signal comes out larger and 180 degrees out of phase. The other aspect of an oscillator is a feedback network which also has an inverting function, but as a result of passing through the network, the signal is attenuated. Therefore, the signal leaves the feedback network 180 degrees out of phase or inverted and reduced in magnitude. Also note that the output of the feedback network is now in phase with the original input of the inverting amplifier. Remember that the feedback network is frequency selective. Therefore, you only get one signal that will arrive back in phase. Feedback networks can function in a variety of ways. In this oscillator example, a phase shift network is employed. This feedback network uses a series of capacitors and resistors to shift the signal's phase by 180 degrees as the signal passes through the network. Each of these capacitor and resistor units will shift the phase of the signal by 60 degrees. However, passing through each unit will also incrementally decrease the size of the signal. So, by the time the signal leaves the network, it will be 180 degrees out of phase and reduced in size. Finally, the 180 degree out of phase attenuated signal will pass through the inverting amplifier where it's amplified and shifted 180 degrees back into phase. In order for the oscillator to produce a repetitive oscillating electrical signal, it must follow two criteria. The circuit must have a loop gain that is greater than 1 and it must maintain its phase state. The phase state is sustained when the inverting amplifier's 180 degree phase shift is reversed by the 180 degree phase shift of the feedback network. Thus, maintaining the phase state is accomplished by a 360 degree change in the phase as a result of the 180 degree signal inversion at both the inverting amplifier and the phase shift network.